are welcome to another part of kinetic theory of gases or gas law. In this very video, I'll be explaining molar volume at STP. So there are two concepts here. The first one we have there is molar volume, while the next one we have is STP. So if I may ask, what's the meaning of STP? STP simply means standard temperature and pressure. So the word STP simply means standard temperature and pressure. So please take note of that. Then we already know that our standard temperature is either 0 degrees Celsius or 0 degrees Celsius or 173 Kelvin. So but most cases we are expected to calculate using Kelvin. Then from pressure we have 1 atm, which is equivalent to 760 millimeters of mercury, which is also equivalent to 760 watts torrent. So that is for standard temperature, and then this is for standard pressure. So what is the molar volume of a gas? The molar volume of a gas is the volume that is occupied by 1 mole of a gas. So the volume that is occupied by 1 mole of a gas is what we call molar volume at STP. So the molar volume of a gas at standard temperature and pressure is the volume of a gas that is occupied by 1 mole of the gas, which is volume per mole. And mathematically, this molar volume of a gas can also be derived using the ideal gas equation, which is PV equals to nRT. I repeat, PV is equals to nRT, whereby P is the pressure, volume, number of mole, rate, and universal gas constant, rather, YT is for the what? The temperature. So please remember, this is the formula we are working with. So if I have PV is equals to nRT, what you are looking for is V all over N. So that is, if I divide both sides by N, I'll have PV all over N is equals to RT. But we are not looking for PV all over N, we are looking for V all over N. So I will divide both sides again by P. If I divide both sides by P, I'll have V all over N is equals to RT all over what? P. So this is the formula for calculating the molar volume at STP. Formula for calculating the molar volume at what? At STP. But before we move on, I want to introduce a concept to us. Remember, the value of the molar gas at STP, I gave you that as an assignment the other time. So the volume of a gas at STP is equals to, please let me show you something first. We have PV is equals to nRT. So if I'm looking for R now, R will be equals to what? PV all over NT, whereby this value of R is equals to 0.08206. Let me just give you 8206. Sometimes they will tell you 0.0821. So but let's work with this value. Then pressure is measured in atm, volume is measured in liter, number of mole is measured per mole, then temperature is measured per Kelvin. So now the formula is the value for the universal gas constant is 0.08206 atm liter mole per Kelvin. So if you see something like that, just know that you are talking about the universal gas what? Constant. I would have shown you the calculation before, but there's no need for, I don't want to show you derivation, but there is need for me to derive the value for this V and N. That is why I have to show you the value of this arrow. We already know that temperature is 0 degrees Celsius, but we can't solve using 0 degrees Celsius. So I'm expected to convert. Please, I want to pay very good attention to what I'm doing, because let me see continue. So you have to convert from 0 degrees Celsius to 273 to Kelvin scale, which is 273 Kelvin. Then our pressure is usually 1 atm. So let's try something out. The formula remains V all over N is equals to RT all over P, whereby V all over N is equals to, what's the value of R? The value of R is 0.08206 atm. As a chemist, you are expected to solve using this parameter, mole, Kelvin, then times the temperature is 273 Kelvin, 273 Kelvin, all over. Then our pressure is 1 atm. So we are talking about the absolute value now is 1 atm. So if you have something like this atm here, we cancel this atm. Kelvin, we cancel per Kelvin. This one means divided by Kelvin. So Kelvin divided by Kelvin, that is already out of the game. So what we are left with is 0.08206 liter per mole times 273 all over what? All over 1. So it's the same thing. So let me push my calculator. If I have 0.08206 times 273, we have 22.4. Yes, so we have 22.4 liter per mole. So that is to say, like what I said, the molar volume of a gas is the volume. The molar volume of a gas at STP is the volume of a gas that is occupied by 1 mole by 1 mole by 1 mole. So the volume of a gas that is occupied by 1 mole is 22.4 liter is the volume of the gas that is occupied by what? By 1 mole. So any question that is being given to you using molar volume of a gas at STP, you are expected to use this in solving. So I repeat, a question might come in this format again. What is the molar volume of a gas at STP? The molar volume of a gas at STP is 22.4 liters. So this is what you are using. So 22.4 liter of a gas is equal to 1 mole. So if you multiply this value by 2 now, which is 44.8 liter of a gas, will be equivalent to how many mole? Equals to 2 mole. So let me quickly give you a calculation regarding this whole mole concept, and let's see how far we can go. Okay, the question says calculate the number of mole of helium in 3.58 liter of helium gas at 1 atm at 0 degrees Celsius. Now, okay, let me show you something first. In fact, let me just go straight instead of me wasting your time. Let me just go straight. 1 atm at 0 degrees Celsius can also be written at STP. So this calculation involves molar volume of a gas at what? STP. So the only parameter that is given to us in this particular equation is 3.58 liters. So what you need to do is that we already know that 22.4 liter is equal to how many mole? 1 mole. So they are not telling us that if someone give you 3.58 liter of that same helium, how many mole will it give to us? This chemistry is very, very easy. This is just the whole useless stuff that was interpreted here. So this is the interpretation. So you cross multiply, you have something like, okay, let me use here 22.4 liter times S is equals to 3.58 times what? 1 mole. And if I divide both sides by 22.4 liter, here will be 22.4 liter. 22.4 liter will cancel 22.4 liter. Then our S is equals to, then if you have something like this, let me have 3.58 divided by 22.4, 0.5 divided by 22.4, yes, it's equals to, our answer will be 0.1598 mole, which can also be written as approximately 0.16 mole. So that would be our answer. So this whole calculation, instead of it to be calculating, converting this one to a temperature in Kelvin scale, you don't need to. This is already at STP, and I tell you that standard temperature is 0 degrees Celsius or 273. The standard pressure is 1 atm, 768 millimeters of mercury, 760 torrent. So whatever they give to you, please, you are not expected to solve using these two values. Our business, if we are dealing with molar volume of a gas at STP, our business should always be with the liters. So it's for you to convert this particular liter. Sorry, we have liter per mole here already. So 204 liter per mole, then 22.4 liter per mole rather is equal to 1 mole. That's 22.4 4 liters is equal to 1 mole. Then this one now will not be how many mole? 3.56 liter per how many mole? So will now be per 0.16 what mole. As easy as ABC. So if you have any question regarding this whole concept, please feel free to ask. But I have a question for you before we go. Now, if someone asks you, calculate the number of mole of, let's say, of hydrogen gas in 40, let me use 44.8. Yes, let's use 44.8 liter of hydrogen gas at, it can't be 1 atm again, at, let me say here is 760 torrents, and then let's say here is 273 what Kelvin. So please do this. If you can get this answer correctly, I'll be very, very glad that indeed you're understanding something. And this answer is very, very cheap, very, very cheap, very, very cheap. So please, everybody, try this, then drop your answer in the comment section. I hope to see you in the next episode. Stay blessed.